Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video we're going to get back to machining a little bit. I've got another one of those, I'll call it hayman jobs, and when I use that term hayman, it's not meant to be a derogatory term at all. In fact, it kind of makes me feel good when one of my friends or neighbors or whatever comes over and asks me if I can help them make a little piece, do a little something. This is actually a simple project, more in the layout than it is the actual work. But my last video, which wasn't a machining video, it's fabrication, pretty much failed. That video on making the cart for the sprayer tank to go behind my zero-turn mower has the least views of any video I've done in the last 3 years. Not sure whether it was the thumbnail, the title, or what, but you guys just didn't watch it, so I get the hint. We're going to go back to using the lathe. Well, not the lathe in this one, but we're going to use the mill and the surface grinder in this project. What I got sent by my friend was just a picture of a piece of probably Delrin block that he uses on a drill press as a template. I'm not exactly sure what it is that he's needs to lay out these holes on, but he asked if I could make him a steel block with space of 113.5 millimeter, which is 4.468 inches on the what we'll call the x-axis, and on the y-axis 72.5 millimeter, which is 2.854 inches. I asked him how thick the material needed to be, and he said he wasn't really sure. But I looked and found that I had a piece of about 3/4 inch material, 8 inches long by just a little less than 4 inches wide. And we discussed it a little bit, and he suggested laying it out. Let me see if I can get this where maybe you can understand what I'm actually going to do. But the pattern sets A, B, C, and D, each one of those has a 72.5 millimeter by 113.5 millimeter, and then we'll start with one set, then we'll move over 1 inch, do another set, B set or pattern, move over an inch and do C, and then D. And with that spacing, that came out to 7.469 inches, and this is 8. So I'm going to turn the camera down here to the workbench and probably do a kind of speedy layout on the filming. But I'm going to lay those 4 patterns out on this piece on the bench, just to use as a sanity check when we get over to the mill. Of course, I'll use the DRO on the mill, but if I lay it out here and then, as I say, as a sanity check when I'm stepping over on the mill, I'll be certain I'm in the right spot. So let me get set up and we'll lay this out. Okay, I'm not sure how much you'll be able to see in the video, but again, these are just sanity marks. These two and these two are set A. These and these are B, C, and D. And I laid that out to be sure I had my measurements correct, that I was coming out about the same distance on each end. And again, we'll use the DRO over on the mill, but these will be sanity checks. All right, I'm over at the mill now, and we're going to put our piece in the vise, but instead of using traditional parallels, the 1/8 inch ones that I have, they're a little too close to the edge. I'm afraid the drill, when it goes through, would hit the parallel. So what I'm using in the middle here are a couple of, they're 1/2 inch by 1 inch high parallels. I'll just stack them together right there. There won't be any drilling in the center, so should be able to drill without hitting. I want to make sure that's good and on the parallels, good and tight, and setting flat. Now we're going to use the edge finder and find this corner right back here to start with. We'll find 0 on that corner. Now we're going to move this in, of course, until it just kicks off. All right, that kicked over just a little bit. I'll 0 out the y-axis. Come up just a little bit. We'll come off the end now. Again, this time we're going to go on the x-axis until it just kicks off. And 0 out the x-axis. All right, this particular probe that I'm using is 200 thousandths thick. So we need to move over 100 thousandths. Which is, of course, half of that. And we'll reset our x-axis to 0. Now on the y, where we had 0 set back here, we need to come in 100 thousandths over there as well. And 0 out the x. I'm sorry, 0 out the y. Now that should put our pointer right on that first mark I made, which is going to be our starting point for everything else. Now, I'm sorry, that put it on the corner. That's what we're finding was the corner. That's 0. Now, according to my drawing, I need to move on the y-axis 0.265. That was on the x. On the y, I need to move 0.298. All this is doing is getting everything centered up. Now, that puts it on that first witness mark that I made. So now I'm going to 0 out the x and y. So this first x position, this first position over here, right here on our drawing, that is 0. All right, now I've just changed my DRO over to millimeters now. Let's see if I've got enough distance, got enough travel there what I'll be doing is center drilling, then we'll drill it out with a bit he wants 1/4 inch holes for the template. What I'm going to do is drill with a bit that's a 1/4 inch minus 1/64. Then we're going to take a reamer, a 1/4 inch reamer that is 1/4 inch plus 1/1000 to finish the hole. I'll probably come back and do that after I do all the drilling. And there'll be a lot of tool changes in this operation, but I think it's just as easy to change the tools out as it would be to move the table so much. I'm pretty sure I don't have room for the reamer. Tell you what, let me go. If I could get this all in one operation, it would be, and not have to keep moving the head up and down, it would be a lot nicer. The question is, though, will it go down enough? Will I have enough quill travel now for the starting drill? Alright, that should give good clearance for a 1/4 inch drill. We will come back and counterbore those holes. Yeah, 1/4 inch drill fits in there with 1/1000 clearance. Okay, I think I might have found a good height on the on the head that I can do all 4 steps at one time. So let's see if this will reach now to do just a little countersink. That's all it needs. So we want to move 72.5 millimeters on the Y. And that should come out on our mark, which sanity mark, which it does. And I have traded the center drill for this starter drill. I think it will work just fine. I think it'll be long enough. $72.5, double check. Yep. Step 1. Step 2, we'll drill it. Step 3, we'll ream. Step 4, we'll counterbore. Now, to get the other side of this first set, we need to go 113.5 millimeters on the x-axis. And this should come out on our sanity mark, which it does. Now we should be able to just move back to 0 on the y-axis. And I'm sure you're aware, but the purpose of using this extremely stiff starter drill here is a normal drill bit a lot of times will wiggle off of your mark if you don't have a starting hole, a hole for it to start in. Now we'll bring our DRO back to 0, 0. All right, now that's the first set of holes. This will be our A set, if you will. For the B set, we need to move over 1 inch. So I just flip my DRO back into Imperial. There's 1 inch. I'll re-zero out the x-axis and do the same thing for the next pattern, then C and then D pattern. I'll bring you back when we getting about ready to finish the drilling up. And don't forget, this is not going to be there's going to be a little more than just the drilling. We'll go over to the surface grinder after this and put a good clean finish on it and good chamfers on all edges. All right, one more check before I take the workpiece out of the vise. I've got a 1/4 inch, 250 thousandths gauge pin here. Let's check all the holes and be sure I didn't miss a step, reaming step. Be pretty obvious if I'd missed the drilling step. Looks like I got a burr on the bottom, yep. All right, all of them drilled, reamed, counterbored. We're going to go to the surface grinder, but before I do, I'm going to just step over to the drill press right quick and knock these with a countersink similar to this one, and knock these burrs off the bottom. Then I'll strip the die cam off of it. I don't want that clogging up my grinding wheel, and we'll get started on the surface grinder. Okay, we're over at the surface grinder now and ready to put some finishing touches on our drill press template. Before I actually laid that out, I went ahead and surface ground the two sides and the ends. I did that setting up and holding it in place with magnetic blocks. And the purpose of doing that ahead of time was so that I had a good square piece to do the layout on. Ordinarily now we would surface grind the flats, each side, and then come back and put the chamfers on. But this piece has already been surface ground several years ago, many years ago. It was in a group of stuff I got from a friend of mine, and he said it had been surface ground, but it's got some surface rust on it now. So since that's already been ground, we're going to put the chamfer on each of the edges all the way around, and then we'll finish it out. We'll redress the wheel and finish the two surfaces. Now some of you, I suspect regular viewers, have seen this chamfering block before. This is affectionately known as a Tom Lipton chamfer block. He showed his in a video once, and then was pretty much bombarded with emails and messages wanting to know the dimensions of it so folks could build their own. I've used this in several videos before. I've got a build video on it. I'll try to remember to post a link to it in the description. But we have a pocket in the back of it that the wheel will go down into. And this is a 90-degree angle right here. So what we do to set that up, get everything out of the way now, and the wheel that I've got on here is pretty much worn down right now, so there's not a diameter wise, so I have to let it down pretty far. Alright, now I've got that centered up in this opening here. Down below down here is a lock for the Z-axis on the DRO, on the surface grinder. So I've got that lock now. Oh, I'm sorry, it's a little too early to lock that one. I made a lock right here for the Y-axis, and since I've got that pretty much centered in there, I'm going to lock that down. Now I've got a little block here on the end, but one more thing I'll say about this. This is an aluminum block, but it's got a steel plate on the bottom of it to react with the mag chuck. So let's go ahead and mag that down now. And then this little block, what I use that for, I'll set that up in here. It's got some pretty sharp edges, and I try to keep them cleaned up and good and pointed as I wear them down. But what we're going to do is gradually move in on the Z until we just barely touch. I'll let it get up to RPM. Alright, we'll set this block in there and just very easily run this in until it touches. Alright, now that that's done, down here on the dial, the Z-axis, I'm going to set it a 0. And then I'm going to move in. I'm going to start with 30 thousandths. I believe that'll be a plenty. What I did was move the table in 30 thousandths from where it touched off. Now I'll reach down and lock the table on the Z-axis. So on the Z-axis and on the Y-axis, everything is locked down. So we'll take our piece of material, and a couple of these edges already had a little chamfer on them. Not sure how well you can see that, but let's put a nice chamfer on our edges. Now these two edges are sharp edges, so it's probably going to grind a little bit more on them. Alright, now that you've seen what's going on, I'm going to close that cover. I think I can still get to it under there. Alright, something I forgot to check before I started this process. To get these end chamfers here, you can see I'm bumping right here without reaching into there. Let me show you the quick fix for that. I'm going to use one of my magnetic transfer blocks because I know it's square. I'll take this loose. And I'll set the transfer block up against the fence back here. Then set this on. Now I should have enough room. As you can see down here, this hangs off the edge. I have to do my touch off again. Again, we'll move in 30 thousandths from where I touched off. And lock the table back down. So I'll unlock both axes again. We need to dress that wheel, so I'm going to use a little diamond surface grinder or diamond dresser. And I never like to touch off under power. I always just manually touch to begin with. Alright, let's bring it back up to RPM again. And there may be just a little bit of extra sparks with a burr coming through. I countersunk that just a little bit on the drill press. But again, there may be just a small burr sticking up there. You can see it's just barely touching now. Alright, I only came down 2 thousandths, and that is cleaning up already. No more than we've got to grind on this. I'm not turning the coolant on. Now for the finishing touch on that, we're going to take a 1/2 thousandths and only step over about 50 thousandths at a time. Alright, I'm just going to make a couple passes back and forth, just letting it spark out. Alright, we're going to flip it over now and do the same thing. And I'm going to advance down on the X, probably 2/1000ths. Now we'll take that 0.5 and just make up our cleanup pass. Okay, I think we're ready to go back over to the workbench and do one more step to this and a quick recap. Okay, as a final touch to this template block, I labeled each section together. This is left side of A, right side of A, B, B, C, C, and D, D. Hope you've enjoyed this little machining project here. Take care, and I'll see you on the next video.